Hello and welcome to Engineering Problem and Solution. And today we are going to focus on the topic which is very popular in electrical engineering, and the topic is called mesh analysis. And I have one example here, and we are going to find the voltage and current in each resistance of the circuit using mesh analysis. So that's what we're going to do here. Now, in this example, what I'm going to do is I'm going to solve this circuit and find the voltage and current using mesh analysis by using step 1, 2, and 3. So I'm going to show you how to solve this circuit by very simple steps, and it's very easy to analyze this circuit. Right, now without delaying anything, let's do the solution. Uh, so the key thing you have to remember that we are applying mesh analysis to solve this circuit. So solution, I'm going to say that um, solution for this circuit, and trying to find here the voltage and current in each resistance using mesh analysis. So that's what we're going to focus. We are going to apply mesh analysis. Now, whenever you are solving any circuit using mesh analysis, there are certain steps you have to follow, and these are the steps. So I'm going to write it down. The step 1. So first step I'm going to say here is step 1. Now first step is to find out the possible number of loops okay, in the circuit. So if you look this circuit, it has basically 2 loops, which you can clearly see. So if you look this circuit here, it has loop 1 like that, and then you have another loop 2 here. Okay, so how many loops in this circuit? In example 1, you can see it has 2 loops. So I'm going to say it's a loop 1 here. Okay, let's use different color. I'm going to say this is my loop 1, and then I'm going to say this is my loop 2. All right. So after understanding loop 1 and loop 2, or finding how many loop you have in the circuit, let's write the second step. Now second step, I'm going to say step 2 is to assign the loop current along with their direction. So it all depends on which direction the current you are assuming. Okay, so that's going to be very important. So always remember, you have to assign the loop current in a direction. So if you look this here for the loop 1, what I'm gonna do is I'm gonna draw another circuit here. Okay, so this is my voltage resistor, another resistor in middle, and then I have another voltage here, and then I have plus minus, this is 20 volt, plus minus, this is 10 volt. The value of the resistor is 3 ohm, 1 ohm, and 2 ohm. So what I'm going to do in this circuit is I'm going to define my loop current. So I will say my loop 1 will have I1 current, and my loop 2 is going to have basically I2. So I will say I2. Now you can see here, like the way I have defined the I2. If you look the voltage source here, that voltage source, if you look the voltage source, you should assume your direction that way, right? Depending on the voltage source. So in reality, the current direction will be like that. It's going from this positive towards the load. So that's how the load, the voltage will move the current around. But you can assume that way, the I2, and you can still get the answer. But the whatever value you will get, the value you will get as a negative. Okay, and that's the difference here. The value you're going to get negative. All right, so the reason I am sticking with the same direction of I1 and I2 is going to make our assumption everything clear. So we're going to stick with the same direction, I1 and I2 as the same direction. You can see this is also clockwise, and it is also a clockwise direction. So that's absolutely fine. So it's always easy if you assume the current direction every loop in the same direction, clockwise. If you assume one anti-clockwise, then it's better to use other also in anti-clockwise. Right, once we did that, now we are going to go to the next steps. Now before we go to next step, whenever you define the mesh current, you should know that whenever current enters in a resistor, entering is positive and leaving is negative. So that's how your polarity is going to change. Same goes with this 2 ohm resistor, current entering positive, leaving negative. Same thing here, entering positive, leaving negative. So make sure that you always write those polarity in the resistor. It's going to give you the positive and negative when we write our KVL equation. The next step is what I was talking about, KVL. Now next step is to apply KVL. Now mesh analysis is also called application of Kirchhoff's voltage law. It is also called application of Kirchhoff's voltage law, which is KVL. So what we have to do in step 3 is to apply KVL in the loop. Now what is the KVL stand for is Kirchhoff's voltage law, and what it states that the sum of the voltage in a closed loop must be 0. And that's what the KVL states. The sum of the voltage in a closed loop must be equals to 0. So that's what we're going to do now. Since we have a two loop 1 and loop 2, we have to apply KVL 2 times in 2 different loops. So I'm going to do this one by one. So applying KVL in loops. So the first, I'm going to say loop 1. Okay, which you can see. Let me write the name also. I'm going to say this is my A, B, C, D. So my loop is going to be A. I'm going to go from A, B, and then C, and then D. That's how I'm going to, and then again going back to, let me write this again because it's a loop. So I need to go back to A. So I'm going to start from A, and go to B, and then go to C, and then then D, and then back to A. So that's how I'm gonna follow my direction. So when I go from A towards B, I saw this value here. Let me use another pen just to highlight blue color. So when I see this 20 volt, so I'm going to use this 20 volt, and once I use 20 volt, I need to represent what value. Is it a positive or negative? So what value is I have to substitute there? Is positive or negative? Now for that you have to see what is the end. What is the end polarity? In this case, because you're going from A to B, you have positive there. So you're gonna use this 20 plus. Then I'm going from B to C, and when I see B to C, I see the voltage of 3 ohm. I see the voltage of 3 ohm there because remember it's KVL. So I'm adding some of the voltage. And what voltage I see in the end? I see minus. Okay, 3 ohm. And then again, I see basically 2 ohm there, which is also minus, which is voltage of 2 ohm. And then when from D to A, no resistor, nothing is there, no voltage source, and that's going back to A, that must be equals to 0, right? Then what we're gonna do, we're gonna basically write Ohm's law, because voltage is nothing but current time resistor. So we have I1 current times resistor is 3. Okay, we are applying Ohm's law here. Similarly for V, voltage equals 2 ohm. Now voltage equals 2 ohm is going to be interesting. Since voltage equals 2 ohm, you can see that 2 ohm basically is your common resistor. 2 ohm is a common resistor. That means current, not only this I1 will pass through there, the effective current between I1 and I2 is going through 2 ohm. So you can't simply write just I1. You can't write simply I1 times 2. That's going to be wrong. Okay, what do you have to do? You have to find the effective current which is going through R2. That effective value of current is going to be simply I1 minus I2. That's the effective current which is going through R2. Now, why I have written I1 minus I2? Because you are in loop 1. So whenever you are in that loop, mention that current first and then another side current. So that's what we're doing here. I1 is first and then take away I2 times 2. Okay, equals to 0. Now what we're going to do, we are going to simplify this. So we have 20 minus 3I1. Let's open this bracket and multiply with 2. We're getting 2I1 plus 2I2 equals to 0. Now let's simplify this. So I have I1 and I1 here. So I'm get minus 5I1 plus 2I2. And let's throw this constant to another side. I'm going to get minus 20. And that's going to be my equation 1. Right, so from loop 1, I got equation 1. And then I'm going to apply my loop 2 now, okay? So A, B, C, D, I'm going to say this is my E and this is my F. This node here, this node here. So for loop 2, I'm going to follow from D to C, and C to E, E to F, and back to D. Okay, and that's what I'm going to apply my KVL or Kirchhoff's voltage law. And again, Kirchhoff's voltage law state that the sum of the voltage inside a closed loop must be equals to 0. So I need to find all the voltage in this loop. So the first voltage I see from D to C is basically 2 volt. Okay, 2 ohm resistor volt, right? Whatever voltage drop in 2 ohm, but it is positive or negative. So I need to mention for this one, I haven't mentioned that. So it's going to be positive here, negative here, because current entering positive, leaving negative for I2. Remember, you're looking I2. I2 is here. So current entering positive, leaving negative. Okay, so that means this is going to be negative. And what voltage you are focusing on? The voltage which is at the end of the polarity. So that's going to be minus. Same thing with your 1 ohm resistor. So you have 1 ohm resistor voltage, and then whatever E to F, we have constant voltage, which is battery source there, which is 10 volt. But it's positive or negative. See, this is the point where you have to look at, or this is the polarity which you have to look at. The polarity which you're looking at here is negative. Okay, and that's why this value is going to be minus 10. I hope you understand this. This is negative here. Okay, so you need to look at the end polarity, which is going from E to F. So we got 10 there, minus 10 equals to 0, because after that from F to D there is nothing, no resistor, no voltage source, nothing. So we got 0. Right, now we need to apply Ohm's law. V equals to I times R. So we're going to apply for 2 ohm resistor. Same thing now. Now problem here, again, 2 ohm resistor is your common resistor. We can't simply write I2 times 2 ohm resistor. Okay, we need to find the effective current which is going through R2. And when you are in loop 2, your effective current going to be I2 minus I1. So that's what is going to happen. Remember that. So it's going to be I2 minus I1. Why? Because you are in a loop 2 side. So first current will be I2, and then take away of your I1, and times with 2, and then we'll go to the voltage drop across 1 ohm. We have I2 times 1 minus 10 equals to 0. Now let's open the bracket. So we're going to get minus and multiply with 2 I2 plus, this is minus times minus, you're going to get plus 2I1 minus I2, because 1 times I2 is going to be I2, minus 10 equals to 0. Let's simplify this furthermore. We're going to get 2I1, and then this is also minus, this is also minus. We're going to get minus 3I2 equals to 10. And this is our equation 2. So once we get two equation 1 and equation 2, and we have two unknown. The unknowns are I1, I2, I1, I2. So we have two unknowns and two equation 1 and equation 2. That means we can simplify this, or we can find the solution using calculator. Now what I'm going to do, I'm going to use my calculator here, and for this I'm going to go to the mode. So let's go to the mode and then find the solution. So we need to find the simultaneous, not the simultaneous one. Yeah, we need to find the simultaneous equation, because we have two equation and we need to go to two order. So this is the one, and then we need to substitute the value. We have to substitute the value such a way that I1 first, and then I2. Okay, so let's use I1 value. I1 from equation 1 is minus 5. The coefficient of I1 is minus 5. Let's use that, minus 5. minus 5 here in terms of A, and in a B we have I2 value, which is 2, and then this is constant, so which is after the equal to. So if you look here, is after the equal to, which is minus 20 from equation 1, minus 20. And then from equation 2 we have I1 value is 2, and then I2 value is minus 3 and 10, minus 3 and 10. And then if I press equal to here, I'm going to get my X value, which is I1 value, which is 3.63. And then Y value, which is I2 value, which is minus 0.909, so on. So let's write that. So from so using calculator, or you can say using or simultaneous equation. So solving above two equation, right? Equations 1 and 2, we get the value of I1 equals to, it was 3.6363 and so on ampere. Remember the direction of this I1? The direction of I1 was clockwise, like that. And I2 we got is minus 0.9. We got 0.93, 0.909. All right, 0 and 9. So just let's go up to 2 decimal point, and remember minus, and since we have a minus, we have this direction. So this answer we can also write in a different way. We can say, or I2 is same magnitude, which is 0.9209 ampere, but direction is like that, anti-clockwise direction. This is also right, and this is also right. So anyone who has assumed the direction which is anti-clockwise in a loop 2 gonna get the value of 0.9 with the positive direction, like that. Okay, so do not get confused. Only the change will happen on those cases when you have a anti-clockwise direction here. The effective current will be not subtract with each other, they will add to each other, because if you look here, the effective current in 2 ohm gonna be add of I1 and I2 rather than subtraction. Okay, it's going to be addition. So yeah, this is our I1 and I2 current going through basically in the loop current. But the question is not about just finding the I1 and I2. It's about finding every possible voltage and the current in the circuit. So what we're going to do now, we are going to find the individual current and the voltage. So let's do that. So let's draw the circuit again. So the circuit we have here is this, and then we have voltage source here, and then we have another voltage source here, and then we have a resistor which is in middle between two loop. And the value of this resistor is 3 ohm, 1 ohm, and this is 2 ohm. This is the value of this voltage is 10. Okay, so this is what I have done differently here. It should be 10. Let's change this to 10. Okay, and then should be fine. 10 and 20, 1 and 2. Yeah. Okay, no problem. So we have, this is our 20 volt plus minus. This is our 10 volt plus minus. And then we have 3 and 1 and 2. So let's do the plus minus here based on our current direction, I1. and based on our current direction here, this is I2. And do not get confused again, because I'm telling you that is the current I'm getting here is negative. If I do the current direction that way, it's going to be positive, because your voltage source is on that direction. Should be fine. It doesn't matter which direction we have, the value is correct. And in this way we can say this is our plus minus here, plus minus here. Right, so let's find the voltage and the current. So first what we're going to do is we're going to find the current through 3 ohm, then 2 ohm, and then 1 ohm. Current through. So let's see what we're gonna see here. Now current through 3 ohm is nothing but I1, because the same is the outer resistor, and the same current will flow in the 3 ohm. That means whatever mesh current you have, whatever loop current you have, is going to be same, because it's outer resistor. So it's going to be same value, which is 3.63 amps. And remember the direction of that. Direction is this way, which is clockwise. And for 2 ohm resistor, now 2 ohm resistor can be tricky. Okay, you need to remember what way your current is going. So you can say I1 minus I2, doesn't matter, right? You can say whatever, you can say I2 minus I1, but you have to put whatever value you have got. If I say this, right, I can use 3.63, which is I1, but my value of I2 I got is minus 0.90. So that's minus, and minus going to become plus, and it's going to give me the positive value. So let's do in calculator. Let's change the mode to math. So I got 3.63 plus 0.90, and I got 4.53. So that means my value is going to be positive, because this minus is going to be positive. That's going to be positive, and that's going to add with this. I'm going to get 4.53 ampere. Now if you ask me now what direction it will be, then the direction will be positive. So what direction will be positive? Is it going to be clockwise, like that? Okay, that clockwise direction here. All right, next one here is 1 ohm, or you can say now 1 ohm. Finally, 1 ohm is whatever is outer resistor, and whatever we have already calculated, which is 0.93, or you can also say I2, which is your minus 0.090 amps. And remember the direction here, we're talking about direction like that, okay, which is a clockwise direction. So yeah, we are done with the current. Now what about the voltage? Now the voltage is the easy part. So, and the voltage across 3 ohm, across 2 ohm, and across 1 ohm. So the voltage is whatever current we have calculated. We have already calculated current, and simply multiplying with the resistor, because your voltage is nothing but current times resistor, isn't it? So we already have the current, which is I1, okay, so which is 3.63 times your resistor value is 3. Okay, so let me write it down this nicely again. So current is I1 times R3, or let's say just simply 3. So we got 3.63 times 3. Okay, so if we use that, 3.63 times 3, 10.89 volt. And then for 2 ohm resistor, now effective current we have already calculated, which is 4.53 times resistor is 2 ohm. So resistor is 2 ohm. So we're going to get 4.53 times 2 ohm, which is 9.06 volts. And the last one is your 1 ohm resistor, and the current which is going through there is basically minus 0.90 times 1 ohm, and we got minus 0.90 volts. That's the voltage there. So all of this is our answer. Let me highlight that. This is our answer. This is our answer. This is our answer. Right? This is our answer here and here. Now if you have to draw this circuit and then write everything there, how it's going to looks like. Okay, so let's do that. The register, the value, register, and the voltage source, plus minus 10 volt, plus minus 20 volt, and then R1, sorry, 3 ohm resistor here. This is 2 ohm resistor, this is 1 ohm resistor. I'm just gonna write the current, and I'm gonna write the value, everything in red color. So I1 is 3.63 amps, I2 is minus 0.90. Remember, if you show this direction, you need to show that's a negative value. The voltage of 3 ohm resistor, voltage across 3 ohm resistor is going to be 10.89. Remember, plus minus here, plus minus, and same thing here, plus minus here. The voltage across 2 ohm resistor is 9.06 volts, and this one here is going to be plus here, minus here, because, or you can say negative, plus here and minus here, but yeah, let's write this as 0.9, not negative voltage, because we have changed this already here. Okay, let's write just volt. All right, so that's done.